Alright, geometry classes, this is Mr. Kim. Go ahead and make sure your homework is out in the workbook. Trade, corrected by CB, top or bottom, your full name. And let's go ahead and get this started. Alright, real quick, a couple things while I move this sign out of the way. The answers are all 1 point each, meaning every answer is a point. So 1 through 15 is all 1 point, but when you get to 16A, that's 1 point, and 16B is 1 point. 17 is all 1 point as well, so that's why there's only 18 problems, or 18 points, because you had an extra point here with the 16A and B. Otherwise, it's all the same. And go through the answers real quick. I abbreviated my answers just so they could all fit inside one slide. So you should have opposite angles in a parallelogram are congruent. I'm not going to grade for that today, but on a future upcoming test or quiz, obviously you want to say in a parallelogram for pretty much all of these. Over here, 11 and 12, when it says show slopes are parallel, you just have to identify that the slopes are parallel. That's just one way. You could also identify the sides are congruent also. So there's more than one way to do it. This is just one recommended way, easiest way. Over here for 13 and 14, these are the complete reasons. So corresponding angles converse is reason 1. Opposite sides are, one pair of opposite sides are congruent and parallel is reason 2. For 14, right angle congruence theorem to prove that the 90-degree angles are equal. And then you have to say opposite angles are congruent in a parallelogram. So that's reason 2. Other than that, it's pretty straightforward. So make sure that you have these reasons. I'm going to ask the teacher, please pause the video so the students can finish up correcting. Alright, now that the homework's all done, you're going to need a sheet of paper for notes, and we're going to go into some proofs today. I'm going to give you some tips first, and then we're going to go into 2 proofs. And we're actually going to do the same proof twice, because I want you to see how you can approach a proof and do a separate thing than, let's say, your friend or myself, but still get it right. So here we go. Next slide. 3, 2, and 1. It's not working for some reason. Oh, there we go. So proving a parallelogram proofs. So this is 8.3 part 2, proving a parallelogram proofs. Alright, some things to avoid using. We want to avoid using these types of things or contents or concepts while doing a proof because they make proofs longer and more challenging, more difficult. So avoid using, write this down, addition postulates, things that you have to do like angle addition, segment addition, where you're adding the values of angles and sides together, because you're just going to make it harder on yourself and you're going to turn like a 4-step proof into a 15-step proof. So please don't do that. The second thing we want to avoid is things like linear pair, supplementary, or complementary, because these things lead into addition postulates. The only reason you'll say linear pair is because then you want to say supplementary, because then you want to say 180 or vice versa, and then you're going to have to add or subtract things, and it's going to get messy. So like I said, they just make proofs become super long and tedious and just hard, and we don't want that. We want them to be easy. We want to know how to do them well, right? Sometimes they might be challenging, but you want to have a good strategy, and these are bad strategies. Okay, moving to the next slide, and 3, 2, 1. Try using, okay, so we just went over avoid using. Try using these. Try using converses to prove parallel sides. Okay, for example, alternate interior angles converse, corresponding angles converse. Right, these are things that you can use that we've done a lot with to prove using angles that sides are parallel. Use CPCTC with triangles to prove sides or angles are congruent, so that then you can say the sides in a parallelogram are congruent. So CPCTC with triangles will help you prove that the sides or angles are congruent. And you want to try using anything that causes segments or angles to be congruent. So your focus is on making things congruent or parallel, not adding or subtracting angles and sides. So I guess that's the best way to sum it up. Make things congruent or parallel, avoid adding and subtracting things to say that. Okay, so even supplementary, not necessarily the best way to go. Alright, so hopefully you got this down. Here we go, 3, 2, and 1. Alright, so here's your first proof. Go ahead and write this diagram down. Alright, we'll give you the given and the the proof at the end here. But for this diagram, we're going to use the same diagram twice. So if you want to go ahead and give yourself some room, we're going to do two proofs with the same given and proof, but we're going to do it two different ways. All right, so give yourself some room. I guess you can mark this diagram up, but then it won't help you for the next one we do because it'll be the same diagram. You can draw it twice though. Here we go. Here's the given and the proof. So given, angle BAC congruent to DCA, angle CAD congruent to ACB. You're proving that ABCD is a parallelogram. Your focus is to use converse statements. Okay, so converse statements, because there's, again, more than one way to do this. So I'm going to mark the given parts that we already have so that we can, make sure that we get it. So let me use black here. All right, so angle BAC is right here, and angle DCA is right here, and angle CAD up here, and angle ACB right here. Alright, so if I'm using converse statements, the only converse statements I know are ones to make sure that the sides are parallel, or lines are parallel. Converse statements don't generally make things congruent, okay, generally. So for example, if I'm looking at this, these are definitely alternate interior, these two right here. And this angle BAC and this one down here, they're also alternate interior. So I'm thinking alternate interior angles converse. Because if I use the converse statements, then up here, we're going to say sides are parallel, and our proof is going to be pretty much done. Because then we can say we have a parallelogram. So give yourself some room here. I'm going to write this out, old-fashioned style. So number one, we're going to rewrite the given statement. So angle ABC, or so angle BAC congruent to angle DCA. And angle CAB congruent to angle ACB. And that's just going to be given for us. Nothing fancy there. Now we're going to use converse statements. Let me erase that. So in step 2, we're going to say sides AB and CD are parallel, or segments. And so that's right here. If you're looking at my arrow, we're going to mark these as parallel. Okay. 1, 2. And we can also go ahead and mark these as parallel because of these two angles, right? This one and this one. So then we'll say AD parallel to BC. And that's going to be alternate interior angles converse because that's what we're using. The positions are alternate interior angles, and we're saying sides are parallel as a result. And lastly, step 3 will be to say that I have a parallelogram. So ABCD is a parallelogram. And because we're using opposite sides of a parallelogram are congruent, that's pretty much the definition of a parallelogram. You can write opposite sides of a parallelogram are congruent, but this one is shorter and easier and helps you remember what the definition is. So that's a focus on using converses, okay? So in general, I'm using angles inside here to then prove that sides are congruent. If sides are parallel, if opposite sides are parallel, I got myself a parallelogram. And we're going to move on in 3, 2, 1. Again, same diagram. Actually, I don't know if it's the same given. You'll see in a second. So same diagram. Yeah, same given. All right. So maybe you don't know your converses. Well, then you can use triangles. Okay. If you don't know your converses, you can use triangles. This is going to be a little bit bigger, or sorry, the longer the proof is going to be. I'm hoping you understand that all the information is the same. Given is the same, prove is the same, except for use triangles now. Diagram is the same. So here's the game plan. The game plan is that we're still going to use the same parts of the triangle. So it's the same parts of the angles. But now we can go ahead and use triangles. So let's just say that we're going to use a reflexive property here. Now we can say that triangles are congruent. So this triangle is congruent to this triangle by reason of angle side angle. If triangles are congruent, then we can use CPCTC, and that's the goal. So CPCTC can be used if you know triangles are congruent. So here we go. Some of you might be thinking, why are we doing it such a long way? Well, if you're in a test or in a situation where you have to do it on your own, and this is the only thing you got, there's more than one way you can do it. So just because it's longer, don't count it out. So number one, same thing as before, angle BAC congruent to angle DCA, and angle CAD congruent to angle ACB. Right? And I'll give myself a little bit more room here. That's going to be one given. I just mentioned the reflexive, right? So let's go ahead and write that down too. We're going to say AC is reflexive to itself, CA, congruent. And now we're going to say triangles are congruent. So step 3 will be, and now let's just pick a good order. Let's start with the one on the left, so ACD. Just kind of try to go alphabetically. So triangle ACD is congruent to triangle CAB. That's the order we have to follow. And that's going to be angle side angle, because the side in between, the reflexive side, is in between the two angles that we're looking at here. So angle side angle congruence. Alright, so that has now all we've done is just prove that the triangles are congruent. Now, because triangles are congruent, and I'll do this in a different color, I'll do it in, let's say, red. Because triangles are congruent now, we can go and say, well, if triangles are congruent, that means the sides that we want are now congruent to each other. Which, why do we want to do that? Because we can also say opposite sides of a parallelogram are also congruent. So there's multiple ways you can do this. You can then still use converses if you wanted. You can go ahead and use this converse. You can prove one pair of sides are congruent and parallel. So you have options, but I'm just opening this up as a method of doing it so that you don't think you have to do it one certain way. So let's use CPCTC and name the, oops, let me change the ink here. Let's use CPCTC and name the sides that we want congruent. So we're going to say AB congruent to CD, sorry, and AD congruent to BC. And again, that's going to be CPCTC, corresponding parts of congruent triangles are congruent. And therefore, since the opposite sides are congruent, now you can say ABCD is a parallelogram. And the theorem we're using is that opposite sides in the parallelogram are congruent. So you have to write that out. Opposite sides in a parallelogram are congruent. There's no definition here. Okay? And that's another way you could do it. So when you do the proofs today, your focus is use converses or use CPCTC if you've got triangles already congruent. From there, figure out how you're going to make sides or angles congruent or sides parallel. It's pretty much your focus, all right? So go ahead. We're going to pass out the homework today and make sure you're working together figuring this stuff out. Good luck, and we'll see you Friday. Bye-bye.